Hi grade 9s, welcome back to another one of our video lessons. So today we're going to continue with more quadrilaterals and geometry. So we left off on exercise 13.3 where you guys had to draw a parallelogram, a square, a kite and an isosceles trapezium indicating all the properties on their diagonals. Okay, so similar to the worked example that I did in the previous video. Alright guys, so I'm going to go through the worked example on page 129 at the bottom and move on. So it says, classify each quadrilateral and briefly justify your answer. The sketches are not drawn according to scale. So guys, remember all the properties of diagonals that we went through on page 128 and top of 129. So that's what you're using to match up the information that is given to us in these drawings, okay? So in the first drawing, we see a quadrilateral ABCD, right? The only information that we are given is that the diagonals bisect each other, okay? Because we can see that when the diagonals intersect, they are equal to each other, okay? They're not all equal, but the diagonals bisect each other, okay? So just based on that fact, we have to narrow it down to what it could be, okay? So if we now look on the previous page, so it says so it's literally the first bullet point or first point on page 128. If the diagonals of the quadrilateral bisect each other, the quadrilateral is a parallelogram. Okay, that's it, guys. That's all we need. So since these diagonals bisect each other, it's definitely a parallelogram. Then what we could, if we had more information, we could classify that parallelogram maybe into a rhombus, maybe into a parallelogram, depending on what else it could be. But given the info that we have, we can only conclude that it is a parallelogram. Okay. Now, if we look at the next diagram, it is a quadrilateral EHGF or EFGH. Okay. Now, they didn't tell us anything about the diagonals in terms of size, but they did tell us that one of the diagonals bisects the two angles on either side, because we can see one is called X and X, and on the other side it's Y and Y. So we only have one diagonal bisecting the two angles, and the two angles are similar, or rather exactly the same on each end of the diagonal. Right, which shape has that? Okay. If we look at the second point on page 129, it says, if one diagonal bisects the corner angles into which it runs, it is a kite. Okay. So if one diagonal bisects the angles into which it runs, so into which it faces, then we have a kite. And that's exactly what we can see on figure EFGH. Okay. All right, guys, so that's how we're going to classify our figures. So exercise 13.4 looks exactly at that. So it says, classify each quadrilateral and briefly justify your answers. The sketches are not drawn according to scale. So guys, this is really where the test comes in, whether you know your stuff or not. These drawings are not according to scale, so you can't visually tell me what it looks like. You have to literally use the information that is given to us to figure this out. Okay. So if we look at number 1A, or 1A rather, sorry, we can see that the diagonals bisect all the angles into x's, okay, which means all the angles are the same. So you now got to think which shape, where if we cross the diagonals, where would they be all equal, okay? And that is a square. It only happens in a square where both diagonals bisect both of the angles on either side. I can even find you the statement for that. Okay, so it says, if both diagonals, so this is the third last point on page 129, if both diagonals bisect the corner angles into which they run, it is a rhombus. It may be a square, but it is a rhombus. So what they're saying is that if both diagonals bisect the angles. But if those angles are also all the same, it's no longer a rhombus, it becomes a square. Okay. So guys, 13.4, you really have to work through these and narrow it down. Draw yourself pictures of these things, what each one should look like, or you can even go onto page 127, which shows you all of the characteristics of the different shapes that we have. Okay, so you don't have to redraw it. Okay, let's continue. So guys, 13.4 I want you to do for homework. So that's classifying. Number 2, complete each of the following statements. Okay, so that you've got to match up those statements to the ones on the previous page and tell me which one are we talking about. Okay. Right, the next example says 1. Classify quadrilateral A, B, C, D, giving reasons for your answers. All right, so let's look at quadrilateral A, B, C, D. What we are given is that we have some sides. We got 8 and 15, okay? We also have angle X, we have angle 2x plus 6 degrees, we have angle Z and angle Y, okay? So that is all that is given. Now, the giveaway here is that the diagonals bisect each other and they are all equal. Okay, so we have to now think, what is the shape that makes that possible? Okay, that all the diagonals are equal. Okay, so guys, you should be thinking either rhombus parallelogram because they are slanted, or square rectangle, or a trapezium and a kite. Okay, those are your 3 possibilities that we might have. So you want to first narrow it down to 1 or 2 options and then narrow it down further. Okay, so what I understand when they say the diagonals bisect each other equally, it means that we must have a shape with a 90-degree angle. Okay, so if I have a rectangle like this and the diagonals bisect each other, all of these are the same. Okay, alternatively, I could also have a square where that is happening, where the diagonals bisect each other and all the things are equal like that. Now, as soon as I have a rhombus or a parallelogram, this is not going to work because remember, our parallelogram is slanted. So this diagonal will always be longer than that other diagonal. So you can already visually see that that is much shorter than that. So if we cut them all in half, they're not going to equal. This piece does not equal to that piece over there. So when the diagonals bisect each other exactly, it must mean that there is a 90-degree angle involved here. Okay, so that's what we're going to use. So we need to now classify this angle, well, this figure. Well, given the distance, as we said, it's either one of these. Can we narrow it down further? Which one is it? Well, in a square, all the sides are equal. Do we have that the sides are equal? No, because we have 8 centimeters, which is AB, and we have AD, which is 15 centimeters. Okay, so the sides are not the same, so it cannot be a square. It has to be a rectangle. Okay. Cool, now that we've done that, right? Number 2 says, determine giving reasons X, Y, and Z. All right, so let's do that. Okay, I'm going to leave this rectangle on. That's our rectangle. So they tell us that this angle is X, and this angle is 2x plus 6 degrees. Okay, but remember, we determined already it's a rectangle, which means that this is a 90-degree angle. Okay, well, we can work out x because we know x plus 2x plus 6 must equal to 90 degrees. Okay, so we can say x plus 2x plus 6 equals to 90 degrees. Okay, what is the reason for this? Well, we can say that, what is this thing called? A, B, C, D. You can say that angle ADC equals to 90 degrees. Okay, that's it. That's our reason. That's all that we are doing. ADC is 90, we proved it before. Now we're just working out for x. So what do we have here? We have 3x equals 2. Take the 6 to the other side, it becomes negative, so it is 84 degrees. Divide by 3, divide by 3. We get that x equals 84 divided by 3 is going to be 26 degrees. Okay, is that correct? Yeah. No, 28. Sorry, 28 degrees. Okay, so we've done that. Okay, let's continue. Then we need to do Z and Y. Okay, angle Z is over here and angle Y is over there. Okay. Right, so guys, remember, this is a rectangle, which means these lines are parallel, which means that angle X is the same as angle Y because we have alt angles over here. Okay, well, that's all we need. We need to say Y equals to 28 degrees. What is our reason for that? Our reason is we have alt angles, so alt angles. Which lines are parallel? AD parallel to BC. Okay, AD parallel to BC. Okay. Then angle Z is this angle over here. Alright, well, let's see what we can do. Well, if this angle X is 28 degrees, we have that these two sides are the same, so this must also be 28 degrees. Okay. Right, well, if we can work out what this angle is, we can do angles on a straight line to get Z. What is this angle here? Well, it's going to be 180 minus 28 minus 28, which is going to be 56. So 180 minus 56 will give me 124. So this is 124 degrees, okay? And that central point is called E. So what we can say is angle ADE equals to 124 degrees. What is the reason? Well, we can say that this is an isosceles triangle. Okay, so ADE, triangle ADE, or rather isosceles triangle ADE. Okay, so that basically explains to me how you got these two. And we've already shown that y is 28. It's an isosceles triangle that will enable us to get the 124. Right, now we need to get z. So z plus 124 degrees equals to 180. What is the reason? It's angles on straight line. Okay, then z would equal to 180 minus 124, which will give us double those, which is 56 degrees. Okay. Now, obviously, what we could have done is we could have used exterior angles of a triangle. So remember, Z is an exterior angle, which equals to two opposite interior angles, which is 28 and 28, which is 56. Okay. So there was even a shorter way to do it than what I did on the board now. Okay. Guys, and there is no right or wrong way. All of these ways are right. One might be a little bit quicker than the other one, but I'm not saying that you must use it this way. There's many ways to look at this problem, okay? Many ways to do it. All right, guys, so that is the worked example there. Number 3, if AB equals 8 and AD equals to 15, calculate BD. All right, so they want us to get BD over here. Well, we know this is a 90-degree angle, so we can use Pythagoras to find this thing. All right, so remember, BD squared equals, the hypotenuse squared equals 8 squared plus 15 squared. Okay, which equals 8 times 8 is 64, plus 15 times 15 is 225. Okay, and that equals 64 plus 225, 280, 289. And then remember, we want to square root both sides. Therefore, BD equals, we root both sides. Root of 289. Root of 289. I don't know in my head. It says it is 17. Okay. So the answer is 17. Is it centimeters? Yes. Alright guys, so that is our hypotenuse, which we use the Pythagoras theorem. I don't know if you guys can see that on the board. Okay, I'm going to use another Koki. Okay, well, I'll use another Koki in the next video. Sorry guys, dropped my lid. But guys, if you're struggling to see what's up there, alright, it's basically just the Pythagoras calculation. And I did speak, I did say it, so if you follow in the book and you can't see, you can at least hear what I'm saying and then you can write it out. Okay. Alright guys, so that gets us to exercise 13.5. Oh, actually, hang on, we didn't finish number 4. Calculate the area of ABCD. Okay, ABCD, area is 8 times 15 because it's a right angle rectangle, which is what we have. Okay, 8 times 15 is 120 centimeters squared. Alright guys, so what I want you to do for homework is 13.4 and 13.5. Okay, and in the next lesson we're going to get onto congruency and I'll explain how we do those types of problems. Okay, so 13.4, 13.5 for homework please. Thanks guys, I'll see you in the next lesson. Cheers.